Welcome back to Topic 6 for Algebra 2, Relations and Functions. In Part 5, we're going to learn specifically about composite functions, or composition of functions. Let's start off with the definition first of composition of functions. This is where one function is inside of another function. And we see it usually in this notation. We have f, a little circle here, which stands for of, g of x. So this would read as f of g of x. Now another way that we could rewrite this would be f parentheses g parentheses x, close the parentheses, close the parentheses. I personally like to write my composite functions this way because it's really easy for me to determine which function is the inside function and which function is the outside function. If we look at this f of g of x, here it is easier to determine that my inside function is g of x. It's like the f function ate g of x, so it's on the inside of it. My outside function is my f of x, because instead of writing x, we're actually inputting the g of x function into wherever we see x in that f of x function. Now, a quick question. Is f of g of x the same as g of f of x? So we can rewrite this as f of g of x and g of f of x. Now here on the left-hand side, g of x is our inner function, but on the right-hand side, g of x is our outer function. Similarly, f of x is our outside function with the first example, but the inside function with the second. So these are not the same. They are not equal. Sometimes when you simplify, you may get the same answer. However, that just might be a coincidence. Let's move into some examples. Our first example here, we have f of g of x with our two functions. F of x is negative 4x plus 9, and g of x is 2x minus 7. Now, I like to solve these problems using these three steps. We're first going to rewrite, then replace, and then simplify. So if we rewrite, we would get f of g of x. Here my inner function is g of x, and my outer function is f of x. Again, it looks like instead of where we would normally have an x right there, we're replacing that with g of x. So moving on to the next step with replace, I'm going to take my outer function and use it as like an outline. So the outer function is negative 4x plus 9. But instead of x, I like to replace it with a set of parentheses. Because inside of those parentheses, where that x originally was, is where we're going to input g of x. In this case, our g of x function is 2x minus 7. So see, we have our outer function of negative 4x plus 9, but instead of x, we're replacing it with our g of x function, or 2x minus 7. Now, in order to simplify this, we would just simplify it like any other algebraic expression. Here, it looks like we want to use the distributive property. So we'll end up getting negative 8x plus 28, and then bring down that plus 9. We can combine the like terms and get negative 8x plus 37. So that is our solution to f of g of x. Let's move on to another example. Here we have the same two functions, but instead of f of g of x, we're going to find g of f of x. So first let's rewrite this. And instead of g of x being my inner function, my inner function here is f of x. My outer function is g of x. So now when we're going to replace, we're going to start using that outer function as our outline. So my outer function is 2x minus 7. But remember, instead of an x, I'm going to put parentheses here. It just helps me personally remember. In my inner function, now I'm going to input that wherever I originally saw x in that first outer function. So instead of 2x minus 7, I'm going to have 2 times negative 4x plus 9. And I chose specifically to use parentheses because if we look at that original outer function in this case, g of x, this is 2 times x. So these parentheses here also symbolize that multiplication. Now we're going to distribute and simplify. So 2 times negative 4x gives us negative 8x. 2 times 9 gives us positive 18. Bring down that minus 7. When we combine our like terms, we get negative 8x plus 11. So in other words, g of f of x equals negative 8x plus 11. Now if we want to compare to example number 1, we have f of g of x, and we got negative 8x plus 37. However, when we flipped it and changed our inner function and our outer function, we ended up with negative 8x plus 11. So this just further proves our point from that first slide that f of g of x does not always equal g of f of x. In example number 3, what we have here is f of g of 2. So instead of x, we actually see a 2. We're going to still rewrite this where we have f of g of 2. So what I'm going to do here is we're still going to identify our inner function and our outer function. Our inner function is g of 2. So again, this is just like evaluating functions from part 3, I believe, with our relation machines. We're just going to input 2 wherever we see an x in that original g of x function. Now my outer function is f of x. So we're going to hold off on that for one quick moment. We can use our f of x as our outline though, which is negative 4 times something plus 9. Now that times something is really our inner function. So our inner function is 2x minus 7. However, like we mentioned here, instead of an x, we actually have a 2. So wherever that inner x is, we're going to replace it. We're going to replace it with a 2. So we can simplify this. Thinking about PEMDAS from the inside out, we're going to look at our parentheses. 2 times 2 is 4. So we're going to have negative 4 times 4 minus 7 plus 9. 4 minus 7 gives us negative 3. Negative 4 times negative 3, keep going with that multiplication, gives us positive 12. And then add 9, and this gives us 21. So in other words, f of g of 2 equals 21. Now notice with examples 1 and 2, I had x in my answer. That's because in our original example, it asked us to find f of g of x or g of f of x. However, in example number 3, we don't see an x. Instead, it gives us a number. So our solution should also be a number. Now what if we have an example where it's f of g of 4? So there's a lot of layers here. First, let's rewrite this. This gives us f of g of 4. Now when we see problems like this, I want you to think about the movie Inside Out. Or Disney Pixar, but to me, this is the easiest way in order to simplify these problems. So our first, if we look at the innermost function, we have g of 4. So I'm going to simplify that, ignoring the other functions right now. Just if we plug in 4 for x in our g of x function, what do we get? We get 2 times 4 minus 7. 2 times 4 is 8. 8 minus 7 equals 1. So that is the output. Now, if we keep going, our next function, keep going the inside out, is f. F of what, though? F of 1. It's the answer of g of 4 that we're then going to plug into our next function. In this case, it's f of x. So we're going to plug in f of 1. This will give us negative 4 times 1 plus 9, which equals negative 4 plus 9, which equals 5. Then, continuing that pattern, you guessed it, we're going to move to our outermost function here. Here we have f. But what are we going to plug in for f? We're going to plug in this 5. Here we get negative 4 times 5 plus 9, which gives us negative 20 plus 9, which equals negative 11. This gives us our final answer. So f of g of 4 equals negative 11. Now, I personally think it's easiest to solve these problems this way. However, if you like to solve it similarly to how we did with example number 3, I'm going to show you how to do that. Again, both of these ways will work. However, you can just choose which way works best for you. This way that we did in example 3, and which I'm going to show you alternatively in example 4, just has a little bit more layers to it, so it can seem a little bit more complicated. We're going to first start off, again, we have that same problem, f of g of 4. But in terms of layering our functions here, we're going to work from the outside in. So we're not going to simplify from the inside out, but we're going to lay it out from the outside in. So I'm going to start us off with our f function, which gives us negative 4 times something plus 9. And I'm personally going to leave a little bit of space here. Our next function, if we work our way inward, is also our f function. So here, in for x, we're going to plug in negative 4 times our x plus 9. Last but not least, our innermost function, we have g of 4. So in my x here, from that second f of x function, I'm going to plug in 2x minus 7. But again, we have that 4 here. So instead of x, I'm going to replace that with my 4. So we will get the same answer in the end, however, it's just a little bit more layered. So we're going to solve this using PEMDAS. We're going to use our innermost parentheses first. 2 times 4 gives us 8. 8 minus 7 gives us 1. So we're going to have negative 4 times negative 4 times 1 plus 9 times negative 4 plus 9. So it's kind of layered in. See, just like what we did in this example previously, we simplified with that g of 4, and now we're going to plug that into our next f function. That's basically what we're doing here. However, the more functions that we have, the larger your composition of function becomes, the more difficult it will be to probably keep track of everything. So we have -4 times 1, which gives us -4. -4 plus 9, that will give us +5. So we'll have -4 times +5 plus 9. That gives us -20 plus 9, which equals -11. So again, here we still have our final answer of f of g of 4, which gives us that numerical value of -11. And that was part 5 for topic 6 for Algebra 2 on composition of functions. Thank you for watching.